you this evening. My name is Julia. I'm a former conservation biologist with the Association of Zoos and Aquariums. I am also a former interpretive naturalist with the U.S. Forest Service, and this is my very first nerd night. So you have the great honor, or dishonor, we'll see how sober I am by the end of this, to bear witness to this historical occasion. So tonight I'm going to be taking all of you zooming in on wildlife. Now to do this, I want you to think about the devices you use in your daily life that allow you to obtain information about the world without physically interacting with it. For me, these devices include my iPhone and my laptop, 2 items I never leave home without. And with them, I can share information on social media, I can check the daily weather forecast, and I can even find my way to a nice restaurant. Hey look, it's High Noon Saloon. Now, as a conservation biologist, I can use them for so much more. I can record and share evidence of wildlife, track animal movements all over the world, and I can even take a detailed snapshot of their habitats from space. May sound like science fiction to some of you, or in the words of Ozzy Osbourne, fucking space age shit. But that is the power of remote sensing. And tonight I'm going to share with you some of the basics of this unique technology and demonstrate how it can be a powerful tool for supporting wildlife conservation. All right, let's get started. So if you have ever heard the term remote sensing before, please make some noise. Okay, great, sounds like quite a few of you. Now for those of you who have not, the definition is actually in the term itself. Remote, which means far away, and sensing, which means to detect. So in a nutshell, it is the scientific process of detecting information about objects that are far away. These objects can be located on the Earth's surface, in the Earth's atmosphere, and even in the depths of space. Now, if you are a student out there, please make some noise. All right, awesome to hear some of you in the audience tonight. For those of you who are, especially for those of you who are in the sciences and the social sciences, I strongly recommend you adding remote sensing to your resume. Not only is this a highly sought after skill by prospective employers, it is also a multifaceted one that can be applied to a variety of different fields and careers. These include some of the following: astronomy, meteorology, hydrology, geography and geosciences, agriculture, urban planning, forestry and natural resource management, and last but certainly not least, military reconnaissance. Now, when applied correctly, remote sensing can also be used to maximize small to large scale ecological data, which can be used to inform wildlife conservation. Let's take a closer look at wildlife conservation. Unfortunately, right now as we speak, wildlife species all over the world are rapidly declining. In fact, scientists now believe that we are witnessing our planet's 6th mass extinction. And this loss is directly linked to habitat loss. Forests, grasslands, wetlands, and coral reefs, for example, are disappearing at an alarming rate. Now, you might be wondering, why use remote sensing to monitor some of these problems? Why not just go into the field? Isn't that where the wild things are? Well, monitoring some of these issues on foot presents several unique challenges. For starters, it's expensive. When you consider how much it costs to hire, train, and deploy field workers, the cost and supplies of equipment, and transportation to and from the research site, field research can cost anywhere from hundreds to tens of thousands of dollars per year, as if we weren't already up to our necks in inflation. Secondly, we are very little people in a very big world. So putting boots on the ground in vast remote areas like oceans, deserts, forests, and steep rugged mountain terrain can not only be time and labor intensive for us, it can also be impractical and at times dangerous for both us and the wildlife that we are trying to study. Finally, as global environmental issues like climate change, development, and pollution continue to combat and compound habitat loss, monitoring these issues will become quintessential to helping remaining populations survive and adjust to our changing world. So through the power of remote sensing, we are able to safely monitor wildlife and at the same time maximize our data collection in a cost-effective way. So hopefully now that we have an idea of what remote sensing is and how we can use it, let's take a closer look at how it works. So like any unique scientific research, remote sensing requires the use of specialized equipment. For this equipment to work, an energy source such as sunlight or sound must be present. Both travel in the form of energy waves, which have unique properties and applications to remote sensing. So understanding how they work is key. Light, for example, travels in the form of electromagnetic radiation, which comprises a range of different wavelengths. These include, if you can see right here, radio waves and microwaves, which are the longest. In the middle, we have infrared light, visible light, which is the tiny portion of light that we humans can see. And we have ultraviolet light, which we cannot see, but that animals like bees and hummingbirds can. Finally, we have X-rays and gamma rays, which are the shortest and the most radioactive of the light waves. Now, sound waves, on the other hand, are pressure waves which require a medium such as air or water to travel through, and this is why sound travels much more slowly compared to light. Now, when these waves travel through our environment, one of three different things can happen. They can be scattered by gases in the atmosphere, which is why we had some blue sky today. They can be absorbed by materials on the Earth's surface, or they can be reflected back into outer space. When these wavelengths are reflected, their information is captured by special devices called sensors, and these sensors will send their information back to a receiver station, including our iPhones and laptops, where we can then pull up the information via our personal computers. Now here we have an example of a sensor that has been mounted onto a satellite. Something I used to tell my interns is that all data, including no data, is like a story because it tells us something. And what we have to say is just as important as how we say it. So with remote sensing, there are a variety of different sensors you can use depending on the type of data you're trying to collect. These can be image-based, as with a camera. They can be sound-based, as with a microphone, or they can be signal-based, as with a radio transmitter. They can also be passive, active, mobile, or static. Passive sensors require an external energy source, such as sunlight or sound, in order to collect data, while active sensors emit their own energy to collect data. Now, mobile sensors will travel across the Earth's surface or in Earth's orbit, collecting information as they go. And finally, static sensors are stationary. This means that they do not move. Instead, they rely on an object to move directly into their path in order to collect information about it. These sensors can also be mounted onto a variety of different platforms. These platforms can be terrestrial, they can be aerial, or they can be spaceborne. Terrestrial sensors are restricted to the ground. Aerial sensors can be launched into Earth's atmosphere, and spaceborne sensors can be launched into, you guessed it, outer space. Today, when most people think of remote sensing, satellites are one of the most common things that come to mind. And while they are one of the most popularly used platforms in remote sensing today, the age of remote sensing did not begin and end with satellites. Remote sensing can actually be traced all the way back to the early 1800s, beginning with photography. So if you are a photographer out there, please make some noise. Okay, sounds like there's a couple of you out there. This is for you. So during the early 1800s, photography was very different from what it is today. There were no iPhones, there were no digital cameras, and there was no Adobe Photoshop. Oh, the horror. And during this time, photography was often a cumbersome and dangerous line of work to be in. Equipment was heavy, it was expensive, and it required specialized knowledge and use of dangerous chemicals like chloride, bromide, and iodine. Basically anything that could kill your brain cells and give you a really bad nosebleed. At this time, early print media consisted of copper plates and glass plates, which were part of the daguerreotype, I can never say that word right, and collodion wet plate processes respectively. And early camera sensors were image-based and passive. Since these early models had to be transported into the field manually, they were also static, and this restricted their use to terrestrial platforms like fence posts, trees, or tripods, as you can see in this photo here. At the time, this also limited their use to landscape photography, as you can see in this image right here. Now, in 1858, the French photographer by the nickname of Nadar, I cannot remember his real name for the life of me, literally took remote sensing photography to new heights when he captured the first aerial footage of the Earth's surface. And this was accomplished by attaching his collodion wet plate model to the basket of his hot air balloon. And here in this picture, we have some of the first aerial footage he was able to capture of Paris at the time from his hot air balloon. Another early form of aerial photography involved mounting cameras onto homing pigeons. And during World War I, these birds were specially trained to capture aerial footage of cities, towns, the countryside, and battlefields, which were either vast or difficult to reach on foot. Remote sensing continued through the early 20th century as the preferred method for surveying areas that were either vast or inaccessible on foot. Now, with the invention of air travel in the early 20th century, around 1930s, early camera models started to advance to more industrial platforms such as airplanes, helicopters, and unmanned airborne vehicles such as drones. And here we have some of the first aerial footage that was captured of Madison, Wisconsin in 1937 from the wing of an aircraft. Now, by the mid-1900s, the first cameras were being mounted onto satellites and launched into space. And this advancement allowed scientists to capture images of entire oceans, forests, and steep rugged mountain terrain that again was either vast or impossible to reach on foot. And this advancement also allowed scientists and members of the community to collect vast swaths of data that covered global changes in land cover over much longer periods of time. Now, around the same time, lasers were also being mounted onto satellites and launched into space, laying the groundwork for a new type of remote sensing photography in the 1970s known as light detection and ranging. Known as LiDAR for short, this type of remote sensing photography officially marked the transition from using passive image-based sensors to active image-based sensors. Using the power of the laser, these LiDAR sensors were able to emit light pulses, which were able to measure the elevations and heights of objects on the Earth's surface. So basically, think of using a giant flashlight to measure how tall you are and what your chemical composition would be for your body. This was the idea with LiDAR. Then using specialized software such as ArcGIS Pro, scientists and members of the community were able to create 3D visual representations, like the ones you see here, of the land. Today, LiDAR is useful for large-scale and long-term ecological projects, such as monitoring forest fires, biomass, glaciations, topography, and other changes in the land cover over time. Now, when applied to wildlife conservation, it is also a useful tool for habitat mapping projects. Here we have an example of some LiDAR data that was captured from Landsat 8 in 2023. This is a 100-meter section of forest located along the Tanana River in northern Alaska. And areas that are highlighted in the green, these represent areas that have high percentages of tree cover, whereas areas that are represented in yellows, reds, and oranges represent much lower percentages of tree cover. So overall, tree cover for this area was significantly low. LiDAR data was also used to measure the heights of individual trees, and for the same area, you might not be able to see it very well on this map, but there are some little red dots on the picture, and each of these little red dots represent the heights of the tallest trees recorded for this area. So since the 1800s, 19th century, whichever floats your boat, remote sensing photography has evolved from using passive image-based sensors to active spaceborne sensors. Today, it is still a popular method used for recording evidence of wildlife and habitat mapping projects. Another popular form of remote sensing photography that I have used in my own research is called camera trapping. Now, camera trapping uses passive remote camera sensors that will detect the motion or body heat of an animal that walks in front of them. And here in this photo, we have a family of white-tailed deer that are browsing through a forest in southern New Hampshire. And this image was captured using a static terrestrial model like the one you see in this image here. These types of remote sensors are useful for short-term ecological projects, such as species occurrence and presence and absence surveys, which cover smaller ecological areas. During the winter of 2019, I used camera trapping to monitor and collect baseline data of local wildlife at a nature preserve in southern Oregon. This was strictly during the winter months. From this type of remote sensing, I was able to collect data of 11 native species that were local to the area. Now, when combined with population modeling, this type of remote sensing is useful for gathering information on species richness, diversity, as well as the occurrence, sex, health, and behavior of individual species. Now, as you may or not be able to see from this chart, overall species diversity and richness for this area were predominantly low. And here I have one of the most interesting finds that I was able to capture during my research. What kind of animal do you guys think this might be? It is indeed a bobcat. Now, in the scientific community, bobcats go by two different names, a scientific name and a common name. But for the sake of the footage I'm about to show you, we're just gonna call him Bob. Okay, Bob, take it away. All right, thanks, Bob. I don't know about you guys, but that is what I call a catwalk. So far, we've mostly covered image-based sensors, which focus on light waves in the middle of the electromagnetic spectrum. Now we're going to shift to signal-based sensors, which focus on radio waves and microwaves. These types of sensors are associated with radio detection and ranging, or radar for short. Now, these types of sensors are mostly active, and they involve using a radio transmitter that detects the direction, distance, and speed, mostly of moving objects on the Earth's surface. They can be mounted onto a variety of different platforms, ranging anywhere from terrestrial to aerial to spaceborne. But what's really unique about these particular sensors is that they can even be mounted onto the animals themselves. Now, unlike the pigeon photography that we saw earlier, which, by the way, is a perfect example of what I think is cruelty to animals, these sensors that you can mount onto living animals are called biologgers, and they are not examples of cruelty to animals. Biologgers will actually trace the movements of the animals that they have been mounted onto, and some of the most popularly used biologgers include radio collars, like the ones you see in this picture here. It's been mounted onto the back of a sage grouse, and they can be traced using antennae like this Yagi seen in this photo here, and they can also be tracked by items like GPSs, which I'm pretty sure you all have on your iPhones. Correct me if I am wrong. So this type of remote sensing, unlike the camera trapping and some of the other photography that we just saw, it's more useful for covering large ecological areas, like the sagebrush steppe in northeastern Oregon. Now this habitat right here that you can see in this picture to the left is called the sagebrush steppe, and it is home to one of the most unique birds that I have ever had the pleasure of tracking. During the pandemic, when we were in the midst of COVID in early 2020, I got to spend my first summer out of graduate school helping doctorate students at Oregon State University with tracking the greater sage grouse. Now, these birds are a critically threatened species, primarily due to the loss of their habitat. This is from juniper encroachment, the fire activity, grazing, and invasive species like cheatgrass and Medusa head rye, which are reducing their habitat astronomically. Now, these birds, in addition to their conservation status, they're also very well known for their mating behavior. Every spring, these birds will gather in groups called leks, where the males will try to attract the attention of the female doing their unique dance, or as I like to call it, the man boob dance. And you guys will see why in this video here, assuming I can get it to play. Let's see. Oops. There we go. All right, so do not call him out on lewd behavior. He has a good excuse. That excuse being the lovely lady who is sitting in my lap. This is the female, who, as you can see, has been radio colored for the upcoming lek. Now, by tracking her movements throughout the year, my colleagues and I were able to determine where she was, how quickly she moved, how big her territory was, and where she was nesting in proximity to certain resources. Now, another type of alternative to using an image-based sensor is using a sound-based sensor. And this type of remote sensing technology is associated with bioacoustics. So instead of using a camera to capture reflected light waves, bioacoustics uses a microphone to capture sound, specifically from animal calls. Right here, whenever we have sound that's been captured, they produce these unique visual representations called spectrograms. Here we have a spectrogram that was taken of a winter wren during the Christmas bird count this year in southern New Hampshire. And this was a significant find for the area because these birds are very rare at this time of year. And This was according to the Cornell Lab of Ornithology. Now, these type of remote sensors, like camera traps, are ideal for small-scale ecological research, which mostly focus on presence and absence surveys, and that cover and that are also used over shorter terms of time. Now, the final type of remote sensing we're going to take a look at this evening is called sound navigation and ranging, known as sonar for short. This is one of the, like aerial photography, it is one of the few forms of remote sensing I've not had the pleasure of actually working with, so I cannot claim credit for what I'm about to show you. This was actually the work of the National Oceanic and Atmospheric Administration. Now, this type of remote sensing is a little different from bioacoustics because even though it relies on sound waves, it doesn't use a microphone to capture sound waves. It actually uses an active sensor which will emit sound waves, and this is kind of like LiDAR, where it measures the heights and depths of objects on the Earth's surface. This type of remote sensing is kind of like echolocation, which is used by bats and whales, dolphins, even shrews, because shrews are a weird-ass animal. And it's to detect objects that you wouldn't be able to use during light. So any area where light could not reach, such as areas on the ocean floor, is more useful for sonar. So as we look to the future of our planet, remote sensing can provide the following benefits to wildlife conservation. It will allow scientists and members of the community to monitor wildlife in a cost-effective way that also helps maximize data collection. It can also help inform wildlife conservation by providing visual, audio, or signal-based information about animal movement ecology, behavioral ecology, numbers, as well as individual species in an area, and habitat mapping. And finally, it provides a safe alternative for humans to monitor wildlife that doesn't put us at risk and that does not put wildlife at risk or alter their behavior in any sort of way. Now, since I do not claim to be an expert on remote sensing, for those of you with curious minds who yearn to know more, I strongly recommend consulting resources like the U.S. Geological Survey, the National Oceanic Atmospheric Administration, or experts at the university to learn more. That's all I have for you this evening, and with that said, we are zooming out on wildlife.
That was a goddamn delight, Julia. Thank you so much. As someone who has tried to use ArcGIS and failed, I'm glad there are smarter people out there than me. We have a lot of questions, so I had to narrow it down. So if you've got a question that doesn't get asked, you can try to grab Julia after this. We're going to start with Amaya, who asks, what tools would you recommend for someone interested in getting started with remote sensing?
Okay, so that's a good question. First off, how many of you, if you have a cell phone, please make some noise. Okay, sounds like most of you. So if you have a cell phone, that is going to be your best tool for getting started, because if you have an iPhone or an Android, then you have the ability to download free apps like the iNaturalist app, or the eBird app, or the eButterfly app, which you can use for taking pictures of or recording sound of any kind of critter that you would find in your backyard. It doesn't cost anything. These sites are specifically for crowdsourcing, and they're really fun tools just to use. So if you ever come across, oh, I hear an interesting bird in my backyard, or I see an interesting little critter and I don't know what it's from, you can take a picture of it, or you can record what it sounds like. You can upload it to the iNaturalist site, which is kind of like the social network for anyone who's a naturalist. And not only can you share it with other people, you can also get feedback from other people who are naturalists who can help you identify what it is if you're not sure.
Yeah, iNaturalist is really cool. I've also used that. It's very user-friendly. Okay, Tyler asks, what is the most novel use of remote sensing that you know of, or maybe that you've used yourself?
Oh boy, you know, I'm not sure. There are still so many sources of remote sensing out there that even I probably don't know about. Probably the bioacoustics, in my personal opinion, it's still a little bit more of a mystery area to me because I've actually had one of my interns a few years ago use it in one of their projects to create some sync music with it, which I thought was pretty fascinating.
Awesome, awesome. All right, and I mean, you said it, so we have to know. Gwen asks, why are shrews so weird?
Okay, so I say weird with love. I don't say it as an insult. I say that they are a weird-ass animal because the further you go back in time, the more you realized how cladistically related wildlife is. Shrews are one of the earliest forms of mammals to walk the earth. And the reason why I say they are weird is because they have a lot of, I'm gonna call them powers or adaptations that you'll find in a lot of other mammals today. And these include things like they have the fastest metabolism out of any animal on this planet, even faster than the hummingbird, which requires a grand total of 50,000 calories per day just to keep it going. And this is why shrews do not live very long. Their quick metabolisms are always keeping them awake, and it's why they only live a grand total of 22 months. That combined with their echolocation, which you can find in modern mammal species like bats, it makes them very unique. So when I say weird, it's a compliment. If I say you're weird, I'm complimenting you.
All right, I'm really glad that Gwen asked that question because that is wild. All right, let's give one more round of applause. Thank you so much, Julia. All right, and everyone, please get home safely. We'll see you next month, April 9th. So please come on back before we have a summer break. So you want to get one more time at Nerd Night before you have to leave us for a couple months. Have a great night. Thank you for being here.
Oh, too late.